Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to show you how to calculate the molar masses of molecules and compounds. So in order to calculate the molar mass of some compounds that you may be given, you need to know that what molar mass is. And molar mass is the amount of mass in grams of 1 mole of any substance. And so, if you know how to calculate the molar mass or find the molar mass of elements, then you can find the molar mass of any compound, any molecule, if you're given the formula. So let's recap or review molar mass with regard to elements. The molar mass of any element on the periodic table is going to be equal to the number that you find for the atomic mass on the periodic table. So let's write that down. So molar mass, that's an ugly M. So molar mass is the mass of 1 mole of a substance and that's in grams. So let's put that in grams. So it's the mass in grams of 1 mole of any substance. Okay, and so if we write also remind ourselves that uh, the molar mass of an element is equal to the average atomic mass on the periodic table. So the molar mass is the mass in grams of 1 mole of that substance. And so, and for every element on the periodic table, that molar mass is the same as the average atomic mass that you find on the periodic table. So that number, if we get my periodic table here, so this periodic table here, you'll notice that in the periodic table, you have these numbers right there below the symbol. That's your average atomic mass. That is the mass of one atom of nickel in what is called AMUs or atomic mass units. So for nickel, one atom of nickel is equal to 58.69 AMUs. Okay, so that number is the exact same number in grams for 1 mole of nickel. So if I weigh out 58.69 grams of nickel, then that's going to be 1 mole. And we all know that 1 mole is equal to what? 1 mole is equal to 6.022 times 10 to the 23rd particles. And what we mean by particles is, of course, atoms, molecules, formula units, things like that. Okay, so if I have a periodic table, then I can look up the atomic masses of any element on here, and that number is going to be the number in grams for 1 mole of that element. So, how does this pertain to molecules and compounds? Well, if I know the atoms that make up a particular substance, then in order to find the molar mass of that molecule or compound, all I need to do is look up the individual molar masses of the elements and add them all together. So let's go ahead and do that. Okay, so here I have 2 hydrogens and I have oxygen in water. Okay, so if I know the molar mass of hydrogen and I know the molar mass of oxygen, I can add those together. So the molar mass of hydrogen, if I look that up on the periodic table, you'll find that it is 1.008. So that means that for 1 mole of your hydrogen, you got 1.008 grams. So that's grams per mole. And then I have oxygen. If you look up oxygen, you're going to find something like 15.9994, right? So 15.9994 grams per mole. So then all I do is, since I have 2 hydrogens, I multiply this by 2 to get 2.016 grams per mole. So now I have this, and then now all I need to do is add the oxygen to the 2 hydrogens, and I've got my molar mass of water. So if I add these 2 together, I get something like 18, a little bit more than 18. But let's go ahead and calculate this out just so that we are complete and accurate. So if I add 15.9994 plus 2.016 equals, and I get 18.05. So 18.0, 15 grams per mole. So that would be the molar mass of water. So let's look at this one. This is acetic acid. So you'll see I have carbon in here, I have hydrogen, I have oxygen. So all I need to do is look on my periodic table for the average atomic masses of each of those elements, and then multiply by the number of atoms for that element that I have. So let's go ahead and do that. So here I have 2 carbons. So carbon, the molar mass of carbon is 12.011 grams per mole. I have 2 of them, so I'm going to have to multiply by 2. And I'll multiply that in a moment. For hydrogen, I have 3 hydrogens plus this one, that's 4 hydrogens. So for hydrogen, again, the molar mass is 1.008 grams per mole. And since I have 4 of them, I'm going to have to multiply that by 4, and I'll get some number. And then finally, I have my oxygen. If you look up oxygen, again, we have 15.9994. And I have 2 of them this time. Oops, I should have grams per mole. And I'm going to multiply that by 2, and I'll get some number. So let's go ahead and calculate that out. So 12.011 times 2 equals, and that gives me 24.011. I probably could have done that in my head. 24.022 grams per mole. And then this is going to be 1.008 times 4 here, 2 times, so it's going to be, this is going to be 4.032 grams per mole. And then this multiplied by 2 is going to be something like 32, or I'm sorry, 30, yeah, but something close to 32. So that's 15.9994 times 2 equals, 31.999. So 31.9998 grams per mole. Now all I need to do is add all of this up. So let's go ahead and add it up. So that plus 4.032 plus 24.022 equals, and so the total is 60.0528 grams per mole. So that is the molar mass of acetic acid. So let's do one more example. So here I have sugar or glucose. So same thing. I have carbon. So carbon, I have 6 of them. Again, it's 12.011 grams per mole times 6. And then I have hydrogen. Again, hydrogen is equal to, it's going to be 1.00, excuse me, 1.008 grams per mole times 12, because I have 12 hydrogens. And then I have 6 oxygen, so oxygen again is going to be 15.9994 grams per mole. I'm going to multiply that by 6 since I have 6 oxygens. And so now I do the calculation again. So 12.011 times 6 equals, and that gives me 72.066. So that's 72.066 grams per mole. And then for hydrogen, that's going to be 12 times 1.008 equals, and that's 12.096 grams per mole. And finally, I have oxygen, so that's 15.9994 times 6 equals, and I get 95.9964 grams per mole. And now all I need to do is just add up the mass of my carbons, the mass of my hydrogens, the mass of my oxygens, and that will be the molar mass of glucose. So let's go ahead and add this together. So 95.9964 plus 12.096 plus 72.066 equals, and I get 180.158 grams per mole. And so that's the molar mass of glucose. So basically what this is saying is if I want to measure out 1 mole of water, then I would have to measure out 18.015 grams, because that's the molar mass of water. So 18.015 grams is equal to 1 mole of water. Same thing for my acetic acid. So if I want 1 mole of acetic acid, I'm going to have to measure out 60.0528 grams. If I want 1 mole of sugar, then I'm going to have to measure out 180.1584 grams of sugar. So I hope this was helpful. If you enjoyed this video, if you learned a lot, great. Please do me a favor, hit the like button, smash it. Also, put a comment in the comment section. Let me know what you think, if you have any questions. And please hit the subscribe button and ring that bell so you can be notified for any other videos that I put out. Thanks for joining me, and have a great day.